Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Asiah binti Ismail. My metric number is DE210102. I am from Group 5, Section 1. So today in this video, me and my group members will be doing a demonstration regarding lab power system part 1 overhead line model, which is computation of line parameters using MATLAB. So let's proceed to the question. First and foremost, let's take a look at the exercise 1. Okay, in exercise 1, the question asks to a 500 kilovolt three-phase transpose line is composed of one SSR 1,272,000 cmil, 45/7 beaten conductor per phase with horizontal conductor configuration as shown in figure 1. So this is the figure 1. The conductors have a diameter of 1.345 inch and a GMR of 0.5328 inch. Find the inductance and capacitance per phase per kilometer of the line and justify the result using MATLAB. So let's take a look at MATLAB. So this is the coding that I got from the provided coding in the lab sheet. So the first line of the coding asks us to insert the distance value between A to B. So from the question we can see the distance value between A to B is 35. So we're going to insert the value here, 35. And then DBC value, so from B to C is also 35. Next is the distance value between C to A. So from C to A, we can see the value is 70. So we're going to insert 70. Next, this is the GMD is equal to DAB times DBC times DCA to the power of 1/3. And then the GMRL value. From the question, we can see the value of GMR is 0.5328 inch divided by, so we're going to divide the value 0.5328 in each divide by 12. So first we're going to display the value of L in millihenry per kilometer, and then L is equal to 0.2 times log GMD over GMRL. And in the line number 8 is asking for a diameter of conductor. From the question, we can see the diameter of the conductor is equal to 1.345 inches. So 1.345 inches. So radian is equal to diameter over 2. GMRC is equal to radius over 12. And then the next thing we're going to display from the execution of this coding is the value of C in microfarad per kilometer. So the C is equal to 0.0556 over log GMD divided by GMRC. So we have finished with the writing of the coding. So next we're going to run the simulation and let's see what is the value of inductor and the capacitance display from the execution of this coding. So we have run the simulation and we can see here the value of L in millihenry per kilometer display is L equal to 1.3802, and the value of C in microfarad per kilometer is C equal to 0.0083. So is this coding is correct or not? We can compare it to the manual calculation of the coding. So we can see, okay, this is the manual solution of the problem 1. The inductance per phase is L equal to 1.38 millihenry per kilometer, which is the same. And then the capacitance per phase is C equal to 0.00883 microfarad per kilometer. So we can say that the execution of the coding from the MATLAB is the same as per the manual calculation. So I think that's all for exercise number 1.
My name is Nurul Syazana, Qhairunessa binti Salleh. My matric number is AE 210029. For this lab, of our system, I will explain the exercise 2. So from the question, we need to find the value of the inductance and capacitance per phase per kilometer by using the MATLAB. So from the lab sheet, they are given the program for exercise 2, and here the coding that we can see for exercise 2. So for this exercise 2, we need to use this program that are provided from the lab sheet. So the first thing we need to copy all this programming. Okay, and then we need to declare all the value they have provided from the question. So we need to declare the distance from A to B. So the distance from A to B is similar from the distance 1 to 2. So the value of distance DAB is 55. And then the value of DBC is also 35. The value of this A is same as like the value from A to C. So from the figure 2, the value of DCA is 70. And then we need to input the value of this diameter in inch. So from the question, we get the value of diameter is 0.677. And then the value of bundle spacing is 18. The value of HMI, the value of R is 0.3924. So after we modify the program from the lab sheet, so we click the enter button, we will get the value of inductance and then the value of capacitor. So to make sure that the value that we get is right, we compare the answer with manual solution. So since I do the exercise 2, okay, here the answer for here's the answer or value for inductance and capacitor. As I compare the both solution for manual solution and for MATLAB solution, I noticed that the both value is the same. So for me, thank you.
For the exercise 3, we need to find the inductance and capacitance per phase per kilometer of the line. And we need to justify the result using MATLAB simulation. This is the coding for exercise 3. And then we run the simulation and we need to enter the S11, S22, and S33. So S11 is 11, 16.5 and 12.5 and enter. Then we need to enter the H12 and H23, which is 7, and 6.5. Enter. Okay, the bundle spacing is 18. Conductor diameter is 1.427. Okay, the GMR is 0.564. Then, as you can see, the GMRL is 1.312, GMRC is 1.0937. The value of inductor is 0.4920 and the capacitor is 0.0232.